Operations and composite functions. Okay, what we're going to look at is how we can take function notation, such as f of x and g of x. We can take function notation and we can write out an instruction that tells us that we need to subtract these, to add them, to multiply, to divide them. Okay, and then later we're going to even talk about what composite functions are, which is to take one function and to place it inside of another one. How do you take g of x and you put it into f of x, or vice versa? But we'll get to that in just a little bit. Okay, example 1. Let f of x be 5x, g of x be x plus 2. Okay, two defined functions. H of x is just going to represent the example that we're going to do. Okay, and now for each of the different h of x's, we have a different operation. We've got subtraction, we've got multiplication. All right, so what I want to start with is showing you the notation of how you can instruct to subtract or multiply. Okay, so two different ways. You could write it like this, okay, and it just says, you can see in parentheses f minus g. Okay, so this is f minus g of x. The instruction from here is telling us whatever the function f is, you are going to subtract g from it. It's a little bit better outlined here, right? It actually says f of x, let's subtract g. Okay, but we could use this notation. Okay, it just sort of depends on what you're working with and who wrote the problem that you're looking at. But both are the same. All right, now how to do this? My suggestion to start most of these problems, except for the division problem, would be to use parentheses around your functions. Okay, so f of x is 5x. I'm going to place that in parentheses. And to be honest, those parentheses aren't going to make any difference at all. But g of x is a binomial. And that needs to be subtracted from the 5x. And I think that these parentheses are important because it tells you that you need to distribute. You need to distribute that negative to the x and the 2. So this actually turns out to be 5x minus x plus, not plus, the whole point was to distribute. That'll be minus 2. Okay, and then to simplify, you can just subtract that x from the 5. You get 4x minus 2. All right, for our second one, multiplication. Again, you can do f times g in parentheses, so f times g of x, or you can just state it this way, f of x multiplied by g of x. All right, again, use parentheses though. We got 5x, then next to that in parentheses, x plus 2. And again, this will highlight that we should be distributing here, that we're going to distribute the 5x to both of those terms, which will give you 5x squared plus 10x. And that's it. All right, for example 2, we can't leave out addition and division, right? You've got 4 basic operations that we should be able to show you. Okay, so here's addition, f plus g in parentheses of x, or you can just simply write f of x plus g of x. Division, you do f divided by g like that, or you can do f of x over g of x, which would indicate the division as well. All right, here's our functions, different than before. You've got x plus 1. We've also got x squared minus 1, which, by the way, that is the difference of squares. So we're going to factor that in just a little bit. Okay, for addition, let's use parentheses. X plus 1 plus x squared minus 1. Okay, now to be honest, these parentheses don't make any difference at all. But it's a good idea to use them because if you have that subtraction problem, it's going to indicate the distribution of that negative. Okay, so it's better just to do everything the same way so that you don't miss it on those important problems. Okay, now adding these together, this will be like terms. So we'll lead with the x squared. We then have an x. Then these two are actually going to cancel out at 0. So that's it. For division, we're going to take x plus 1 and divide it by x squared minus 1. And as mentioned before, this is actually the difference of squares. It does factor. You get x plus 1 matching. You get x minus 1. Okay, it factors into the conjugates, x plus 1, x minus 1. The x plus 1 can cancel with the other x plus 1. And that leaves us with 1 divided by x minus 1. All right, for example 3, we're going to evaluate the difference in the product of two functions given a certain value. All right, so the functions we start off with, f of x is equal to 3x minus 4, g of x is going to be equal to negative x squared. Okay, we're going to take the difference and evaluate for 3. So you actually have two approaches at this. You could do what we just looked at where you subtract the two functions first and you create a new function representing the difference, which you can plug the 3 in. However, in most cases, what I think is easier to do here is just to plug that value into each of the functions, then take the difference of them. Okay, so if the 3 goes in for the f function, you're going to get what would be 9 minus 4, so you get a 5. We can then subtract whatever 3 evaluates in here. Okay, so when the 3 goes in here, it's going to get squared first, which is going to give you a 9. That will then become negative 9. All right, so we end up with 5 minus negative 9, which is the same thing as 5 plus 9. So that gives us 14. All right, so next, f times g of 1. And again, what I think is easier is if you take that 1 and you plug it into both functions, then take those answers and multiply them together. Okay, so if we plug the 1 into 3x minus 4, you're going to get 3 minus 4, which is negative 1. When you plug it in here, you're going to get 1 squared, which is 1, but becomes negative. And all together, that equals positive 1. The other item that I wanted to talk about was composite functions. A composite function occurs when one function is the input of another. All right, so what we literally do is we take an entire function and we make that the input to another function. We're going to take an entire function and we're going to plug it in wherever we see the x or the independent variable. Two different ways we can describe this as notation. We can make it look like this. We can also make it look like that. Okay, the first will be read as f composite g of x. This is f composite g of x. The other is going to be f of g of x. Both are going to tell us that the g function is going to go inside of the f function. All right, I don't think it's as clear here, but just sort of read it backwards. The g function is going to go into the f function. All right, so given these two functions, f of x and g of x, we're going to do both versions. We're going to do f composite g of x or f of g of x. We're also going to do g of f of x. All right, so let's look at the first one. F of g of x. What we do for that is we use f as an overall basis for our function, which is going to be the 3x minus 14. Okay, so you have 3, but instead of the x, what we're going to do is take the entire g function. We're going to take that entire expression and we're going to place it there. So I'm going to open up parentheses, fairly large, then say minus 14. Okay, they're large enough that I can take the g function and put that in there. And all we're going to do from there is simplify. We're going to distribute the 3. So you get 3x squared plus 15 minus 14. These can group to a 1. And that's it. All right, now, g of f of x. We're going to use g as the template. Okay? G of f of x. So the template is going to be x squared plus 5. So big parentheses, squared, plus 5. In those big parentheses, we're going to put 3x minus 14. Unfortunately, we do have a binomial to the second power. All right, so for that, we're going to expand it out. We're going to get, not a 3, we're going to get 3x times 3x. That'll be 9x squared. You're going to get 3x times negative 14, which is going to be negative 42x. Negative 42x. Let me show you that. We got 3 times 14. That'll give you 42, but it's a negative 42. You're also going to get that again with negative 14 times 3x. So it's going to double up. You're going to get negative 84x. We then have negative 14 times negative 14, which is positive 196 plus 5. Okay, so we could write this as 9x squared minus 84x. These will group to plus 201. All right, last example 5, we are going to evaluate the composition of functions. We're going to evaluate f of g of 4. We're going to evaluate g of f of 4. Okay, and there's 2 approaches that you can do with this, just like I showed with operations. You could first build the composition, which we did. We could build the composition and evaluate it. Or what we could do is take that 4, plug it into the g function, then take that answer and plug it into the f function. Okay? Let's go ahead and just look at what it would be like if you plug the 4 into that. So you'd have 3 times 4 squared plus 1. Okay, now 4 squared is 16. 16 times 3 is 48. 48 plus 1 is going to equal 49. That's that first one. So that is f of g of 4. However, if you did not build the function, if you didn't build the function, what you could do is take the 4 and plug it into the g function, which would look like this. You'd have 4 squared plus 5. Okay, that's coming from the g function up here. That will evaluate as 21. You could then take that answer and put it into the f function. So you'd have 3 times 21, c minus 14. That would be equal to 63. And if you subtract 14 from 63, you still get 49. Okay, so if you've already got the composition built, I suppose that would be faster. But if you don't have the composition built, I think this might be faster. Plug it into the g function, then plug it into the f function. All right, let's go ahead and do it that way for g of f of 4. Let's go ahead and plug the 4 in to the f function, which is here. So you're going to get 3 times 4 minus 14. All right, so then that will give us 12. Let's see, that'll give us 12 minus 14, which is equal to negative 2. That answer can then go into the g function. So the g function is x squared plus 5. We'll take negative 2, we'll square that, plus 5. Okay, negative 2 squared is going to give you a 4 plus 5, which is equal to 9. All right, but let's go ahead and plug in the 4 into that expression, see that it is the same thing. Okay, so we're going to have 9 times 4 squared. We're going to subtract 84 times 4 plus 201, and you still get 9. Okay, so even though we had that as an expression, if you had to do that math by hand, that would take a lot longer than doing it by this method.
Wait, what?